Hi, this is Akshay Naveen pursuing mechanical engineering third year, and I'm going to give a brief explanation about Pdc machine and its working. So Pdc machines are classified into two types. One is high pressure die casting machine and the other is low pressure die casting machine. It is just based on the capacity of the machine. Capacity of the PDC machine is specified in terms of tonnage. So tonnage is nothing but it is the maximum force the locking mechanism, that is the toggle mechanism, can withstand, and machine with capacities of 250 tons to 800 tons is classified as a low pressure die casting machine, and machine with um, capacity of 840 tons to 3200 tons are classified as high pressure die casting machines. So now let's move on to cost of PDC machines. So it varies from few lakhs to some crores. So for low pressure die casting machine, the cost varies from 10 lakhs to 15 lakhs, and for high pressure die casting machine, it is about 1 crore or more. So this is a locking mechanism used in pressure die casting machine, and it is actually known as toggle mechanism. It's composed of two sets of kinematic links, and each contains three joints and five turning pairs. So these are the three joints, one, two, and three, and there are totally five turning pairs in each sets of kinematic links. So there are two types of die in this pressure die casting machine. So this is the stationary die and this is the moving die. So now let's see something in detail about these two dies. And this is the schematic representation of a pressure die casting machine, and this is the moving die and this is the stationary die, and the movement of the moving die is controlled by a double acting hydraulic cylinder. The moving die also composed of a ejector pin setup and a toggle mechanism which is used for locking purpose, and the ejector pin setup is pneumatic driven and is mostly automatic, and at rare cases it is manually actuated by using foot pedals. It is used to eject the casted component out of the die cavity. This is the stationary die whose motion is constrained, and it is composed of a plunger setup. It is used to push and pressurize the molten aluminum or zinc through the gate area, and the gate area is nothing but it is the inlet to the die cavity. Now let's move on to the pressure die casting process. It is done in three stages. It signifies the plunger rod movement. In first is the slow phase, where the plunger rod moves with a velocity of 0.1 meter per second to 1 meter per second, where the molten metal starts to move towards the die gate area. This slow phase is done in order to reduce the turbulence in the flow of the molten metal. Turbulence leads to air entrapment, and that in turn leads to hydrogen pinholes and blowholes like defects. The next phase is the fast phase, where the velocity of the plunger rod is around 2.5 to 6 meter per second. The third phase is the intensification phase, which pressurizes the molten metal to fill in all the spaces of the die cavity. Now let's discuss about the cooling techniques in PDC machine. In pressure die casting, the die temperature should be maintained around 100 degrees Celsius for instant solidification. Since the solidification time in PDC process is around 10 seconds, so these cooling techniques are used to maintain the die temperature. First is thermoregulation, where water or oil at ambient pressure and temperature is allowed to pass through the uh, coolant valves, and the next comes the pump cooling, where they uses a positive displacement pump in order to maintain 2 to 6 bar pressure, and it has some time limit. So this process, pump cooling process, happens between two different cycles. And now comes the jet cooling. Here they uses a non-positive displacement pump, so the pressure is ambient pressure, and it also has the time limit. So this process also happens between cycles. So next, the last is continuous cooling. So this process doesn't have any time limit. So it happens through the cycles, not in between the cycle. It also uses a positive displacement pump so as to maintain a pressure of oil or water between 1 to 2 bar.